Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on lines with one intercept. Now we better go through this because the method we went through last time, finding the x and y intercept and then plotting them, that won't always work. Not every line has both an x and a y intercept. Sometimes the x and y intercept is the same point. Let's look at an example. Let's say I wanted to graph y equals 2x. So if I try to use the x-y intercept method, so if I say x is 0, that will mean y is 2 times 0, which is 0. But if I let y equal 0, then x equals 0. What's happening here for the line y equals 2x is the x-intercept is 0, the y-intercept is 0. Both the x and y intercept are the same point, the origin, 0, 0. But remember, we need a second point to be able to graph any line. So what we're going to do, if we have something that's in the form y equals some number times x, we're going to plot the intercept at 0, 0. That's one point, but we can't find another intercept. So what we're going to do is you're going to sub x equals 1 to find the y value, and then you're going to plot that second point. That's how we're going to have to handle ones like this. So for y equals 2x, we've got 1 point, 0, 0. To find the second point, we're going to let x equal 1. So if x equals 1 in this equation, y is 2 times 1, which is 2. So I'm going to plot the point 1, x equals 1, y equals 2. So I go across to x equals 1 and y equals 2. Now I have a second point, and I can simply join up those 2 points. So we join the 2 points. Once again, you need to put arrows at the end and label with the equation y equals 2x. So what if the equation I wanted to plot was y equals, say, negative 3x? Well, we're going to do the same thing. We're going to plot the origin 0, 0, and then we're going to let x equal 1. So if x equals 1, y is just minus 3. Hopefully you see if x equals 1, y is just that number in front of x. So I'm now going to plot the point 1 minus 3. So this time, 1 minus 3, it goes down from the origin. So once again, I've got 2 points. I can just plot them and join them up. So once again, once we've joined it up, arrows on the end to indicate that it goes forever, and write the equation y equals minus 3x, okay? So I'm going to rub out the right-hand side of this slide. Please pause and copy down if you need. So that was for lines in the form y equals kx, but there's also some lines that only have one intercept. So if we have something like x equals a number, no y in it, that is a perfectly vertical line. And if we have y equals some number, that's a perfectly horizontal line. So make sure you don't get mixed up. It sort of goes in the opposite way you'd expect. The x-axis is horizontal, so you might think x equals a number would be perfectly horizontal, but it's the other way around. So let's say I wanted to graph, for example, the line x equals 2. So we know the x-intercept is 2, but it doesn't have a y-intercept. It's a perfectly vertical line through x equals 2. So all we do is just draw a line that goes through x equals 2, just like that. Once again, we do have to put arrows on and label our equation. If I wanted to graph the line, I'll do this in blue, y equals minus 3. So the y-intercept is minus 3, but there's no x-intercept. So y equals minus 3 will be a perfectly horizontal line through minus 3. That's the y-intercept. So it will look like that. Once again, we put arrows at the end and we label our line. Okay, so make sure you note the difference. Firstly, we went through y equals kx. There is a y and an x, but there's no constant term. We did that differently. Plot the origin, and then let x equals 1 to find a second point. But if it's x equals a number or y equals a number, we do it differently. X equals a number is vertical, y equals a number horizontal, like we just did. All right, thank you so much for tuning into this video. Please ask if there are any questions. This has been the luckiest maths teacher in the world. Have a great day.